Vector algebra.
Okay, so today we want to look at the unit vector. Under vector algebra, I want to look at a unit vector. Now, what is a unit vector? A unit vector is simply a vector with length equal to 1. So any vector that has length or that has a magnitude of 1 is called unit, as you get it from the word unit. So any vector with length 1 is a unit vector. So I, J, and K, they are all unit vectors. I, J, and K are all unit vectors. So now when we are doing the complex numbers, we even find I was equal to I squared was equal to what? -1. So they all have the magnitude of what? Of 1. That's the I, the J, and K. They are all equal to 1. Now, what happens is that if you have a vector A which is not equal to 0, then the unit vector, you have a vector A which is not equal to 0, then the unit vector that has the same direction as A, the unit vector that has the same direction as A, then the unit vector that has the same direction as A is given as U. Now, unit vector is represented by what? U, or is denoted by what? U. That unit vector is now given as U, 1 over the magnitude of the vector times the vector itself. 1 over the magnitude of the vector times the vector itself, which is simply equal to the vector divided by the magnitude of what? Of itself. 1 over the magnitude of the vector times the vector itself, which is equal to the vector divided by the magnitude of what? Of itself. Now, how do we verify this? Okay, so let's look at verification. So with the verification, what I want to understand is that let C be equal to 1 divided by the magnitude of the vector A. Let C be equal to 1 divided by the magnitude of the vector A. Then we can say that U is therefore equal to what? C on A. U is therefore equal to what? C on A. U is therefore equal to what? C on A. Now, if U is therefore equal to C on A, the C we are considering here is what? A positive scalar quantity. Or it's a positive scalar. We want to know whether, you say unit vector has its length as 1. So we want to know whether when we verify this, we will get what? We will get 1. So we first consider C to be equal to 1 over a magnitude of a vector A. If that is true, then U here is equal to 1 over the magnitude of vector A is what represented by C as a scalar to multiply the vector itself. So we are multiplying the vector scalar, the vector by what? A scalar to give the unit vector. Alright. So if this is so, then we can say U is equal to what? CA. Now let's take the magnitude of both sides. And now when you take the magnitude of a unit vector, it should give you what? 1. Because the magnitude, a unit vector has length what? A 1. Okay, so when you take magnitude of both sides, you get magnitude of what? Of CA. Alright, so now we have magnitude of the U is equal to magnitude of the C times the magnitude of what? Of the A. This is the property. So it stands. Alright. Now what happens is that the magnitude of the U here is the same as 1 over what? C is what? 1 over this magnitude dot the magnitude of what? Of the A. Now when you do this, what happens is that this magnitude can easily cancel this magnitude. So therefore, the magnitude of the unit vector is equal to what? 1. And if the magnitude of the unit vector is then equal to 1, then the formula holds that the unit vector is always equal to the vector itself divided by what? X magnitude. The vector itself divided by X magnitude. So let's take only one example and look at it. Find the unit vector. Find the unit vector in the direction of the vector, in the direction of the vector 2I minus j minus what? 2k. Take note, the reason I'm using the direction is that we said if a vector A is not equal to 0, then the unit vector that had the same direction as what? The vector A. It was the formula that we just proved over here. So now, if the formula we just proved over here, the question says that you find a unit vector in the direction of this particular what? Vector. If they have the same direction, you prove that the unit vector is 1 over the magnitude of the vector itself times what? The vector. So now, what happens is that you have to find the magnitude of this vector. 2I minus j minus 2k. So the magnitude of this vector is simply equal to 2 square minus 2 square minus plus minus 1 square plus minus 2 what? 2 square. That's 2 minus 1 minus 2. I get it. And when you do this, you are getting 3. So you get root of 9, which you give what? 3. So therefore, the magnitude of the vector there is what? Is 3. So therefore, A divided by what? The magnitude of the vector itself. And if the vector is this, then it is equal to what? 1 divided by 3 times what? The vector itself. And what is the vector? 2I minus j minus what? 2k. So 1 divided by the magnitude of the vector times the vector itself. And when you get this, then the unit vector u is therefore equal to what? You multiply 1/3 by all this, so you get 2I minus 3 divided by 3 minus j divided by 3 minus 2 on 3 k minus 2 on 3k. So this is the unit vector for this particular question, or in the direction of this vector. Thank you very much for joining.